So, what can I say? Good afternoon, everyone. This is like one more session of the Pythagoras seminar talks around how to teach mathematics. We are fortunate that the last I will say 1 year and a half we have hosted very nice speakers, and this is also the case of today. So today we host Professor Marina Marchicio Conte from the University of Torino, or Turin, in English. Marina is like a professor of mathematics at the University of Torino. She is a delegate for the development and promotion of the university's digital education strategies, something very, I will say, of high priority, especially after COVID. She also has a position as a math and scientific disciplines with digital methodology and innovation technologies for her university, or these are, among her research interests. So her research interests include digital education, math and scientific disciplines with digital methodology and innovation technologies. Her work has received more than 2,000 citations, and today she's going to share with us her wisdom, her knowledge about the topic that is very much matched with her research interest, teaching and learning mathematics in a digital learning environment. I would like to thank you, Marina, for your availability, despite of your very busy schedule, to be with us. We appreciate very much. Thank you.
Could you hear me?
Very well.
Okay. Thank you very much for your kind invitation, and it's an honor for me to speak in this very interesting series of conferences. Thank you also for the presentation. Let me start to say very few words about my university. The University of Turin. It was founded in 1404. And is one of the most ancient and largest university in Italy, because it has around 83,000 students. You can see very new and very old buildings all over the town of Torino. And at University of Turin are organized the courses in all disciplines except engineer and architecture. This is my research group. It's called Delta. Delta means Digital Education for Learning and Teaching Advances, and you can also follow us through the social that you can see. Let me start speaking about digital learning environment, which is the topic of this talk, and also digital learning environment for teaching, in particular mathematics. Let me start from the first word, digital, and we can ask what does it mean and is it important or not. All this research is inside the European framework, and I can say that there is at least 3 very important documents connected with the digital learning environment and teaching and learning inside it. Digicompedu, which is a document special which describes the key areas of digital competencies for educators. The Digital Education Action Plan 21-27 and the Digicom 2.2. The first document is a framework for educators at all levels of education, and because teachers and students are in this document, teachers and students are the main focus, and in particular there is a lot of attention about people that train teachers in order to allow them to develop digital skills and that then they can use in their teaching. You can see that the main competence areas, professional engagement, digital resources, assessment, teaching and learning, empowering learners, facilitating learners' digital competences. And we can see later that inside a digital learning environment, we can develop all these areas. For the second document, all of us know him. The European Community published it in September 2020 after the pandemic of COVID. And the main goal is to allow the population to develop basic digital skills. And in particular, there are two strategic priorities. The first one is fostering the development of a high-performing digital education ecosystem, and the second, enhancing digital skill and competencies for digital transformation. These two priorities, they are very well explained, but it is if we can see later that if we decide to use for teaching and learning, in particular mathematics, but for all disciplines, a digital learning environment, we go in this direction. In this document, there is also a lot of information about high quality learning content, in particular open educational resources. The European Commission decided also to develop a European Digital Education Hub. If you had already the occasion to visit it, you know that the aim is to overcome the fragmentation of digital education policies, research and implementation practice at a European level. Is also another aim is to share good practices, peer learning, collaborating in all areas of education and training. And all of us can become a member of this digital education hub. The third document is connected to the digital competencies. It's called 2.2 because it's a new version of the first version of 2017, because this new document speaks about digital environment, but connected also the new tools of the artificial intelligence, in particular the tools connected to generative artificial intelligence. Then, finally, in each country of Europe, there is a national policy. For instance, here in Italy, the Italian Ministry of Research and university decided to invest in 3 specific digital education hubs and in the production of a lot of MOOCs for teachers. Go to learning environment. Let me recall what is a learning environment and what elements should be included. But a learning environment is a place where learning is fostered and supported. And it includes at least 2 elements, learner or learners. It's better if you have more than one learner, and the setting or space wherein the learning acts with tutor, with teacher, with peer, and so on. Using different tools, also a computer or paper, and so on. I like very much to use this word, ecosystem. This word becomes from biology. What is an ecosystem in biology? In biology, ecosystem is a complex of living organisms. So there is life inside, in their physical environment, and all their interrelationship in a particular unit of space. This is the definition that you can find in the Encyclopedia Britannica. I like this word because I define a digital learning environment as a learning ecosystem in which teaching, learning, and the development of competencies are fostered in classroom-based, online, blended, or hybrid settings. And it is composed by a human component, a technological component, and the interrelationship between the two. You can see in the slides, there is in the middle, it's very important, the learning community, but there are there are these arrows show that there are a communication between the learning community with devices, with the learning management system. The learning community uses activities, no, do activities and uses does activities and uses resources, and there are also systems and tools in order to collect the data. So I want to summarize saying that we have this human component, teacher, student, tutors, technological component, but I want to say something more now later, and interrelation. Inside the interrelationship, I put also the methodologies, didactic methodologies, interaction, and also all contents available. For mathematics, the technology component of a digital learning environment is very important. I try to summarize in these slides that, first of all, it is very important to have a learning management system. I wrote Moodle because in Italy it's very, very, very common that universities and also secondary school use Moodle. But of course, it is not important which learning management system you can use. But there are a lot of integration with this learning management system. For instance, you can see first of all, on the top, you can see easy reading font. This is a font that we discovered that it was invented here in Torino. We were very surprised, but it is a font very useful for people, for instance, with for dyslexic people. But it's very high, it's very comfortable for everyone. But you can see on the left and on the right with the integration with an advanced computer environment, an automatic assessment system, but also integration with the web conference system. Let me say a few words about this integration, which is very useful, especially for mathematics. An advanced computing environment, for instance, here in Torino, we use Maple, but there are also other advanced computer environment like Mathematica or others. Is a system which allows to embed in interactive worksheet text, numbers, symbols. You can do geometric visualizations. You can build interactive components. You can have algorithms and procedures very useful in order to learn mathematics, because it's possible to have an active use of this advanced computer environment, because students can use it in order to develop problem solving skill, as we can see later. And we can also put this worksheet, and this worksheet are still interactive, also if the students don't have the advanced computer environment on their computers. This is also very important. Is an advantage if you use a digital learning environment integrated with this advanced computing environment. But a teacher can also create interactive worksheet in order to overcome difficulties, to boost math competencies, in order to allow students to study, review, understand theoretical concepts, or as we see later, to develop a problem solving skills. The other very useful tool for mathematics is this automatic assessment system. What does it mean? It means to have something very different from multiple choices that you can prepare quizzes with multiple choices also with the learning management system. But it means to have algorithm-based questions. I prepare one question, but I have infinite questions with the different numbers of the same level of difficulty. It means to have a system that gives immediate feedback to the students. It means that there is a mathematical engine behind, so it is can recognize the answers independently from the infinitive equivalent way in which I can write a formula. And this is very, very important. But it means to have a tool that when I prepare a question, if the students answer in a correct way, okay. But if the students makes an error, it starts a step-by-step solving process that cut the first question in sub-question and allow to the students to arrive to the right answer. And this is very important. It means to have a tool which allow you, in mathematics, for instance, to use different kind of representation, a numerical table, for instance, but also a geometric representation. And it means to have a tool that allow you to present real-world problems and to allow the students to solve the problems in a guided way. Of course, if I have in this technological component, I can insert also a lot of artificial intelligence tools, in particular generative artificial intelligence. For learning with artificial intelligence, it means to use the artificial intelligence power tools in classrooms, but also it means to allow our students to learn about artificial intelligence and also to prepare them for artificial intelligence. And this is very, very important. But, okay, can go. Just to say very quickly, because this is not the main focus, but also in particular for mathematics, we can, if you have, you can use the tools of generative artificial intelligence in order to solve problems and in particular to discuss with your students if, for instance, ChatGPT, in the slides we use it, ChatGPT with our students, to discuss with them the suggestion that it gives, if they are correct or not, and it allows the students to develop also critical thinking. This is an example of course inside the digital learning environment where you can find activities, different interactive files, quiz, glossary, submission of assignment, but there is also different kinds of resources from static pages, but also videos, podcasts, and so on. What is interesting, we can see different icons for different kinds of resources. For instance, you can see we can organize the courses with a modular structure in order to allow micro-learning. And in the module, you can find files in order to review the theory, For instance, you can see here the Moodle pages or interactive worksheet prepared with using Maple in order to allow our students to make explorative interactive activities. And then there are tests with automatic assessment, but there are problems in order to be solved. But there is also tools in order to allow students to check their progress. For instance, this is the completion bar progress. So a digital learning environment can be used in different contexts, modalities, face-to-face in the class, online, pure online, blended, part online, part in present, hybrid, students in present or at home, but also in different modalities with respect not only the space, but also the time. It means we can use it in a synchronous way, but also in an asynchronous way. And we can insert inside a lot of different asynchronous activities, discussion, automatic assessment tests.
Marina,
Yes.
what is the difference between the blended and the hybrid?
We usually blended means that we have all together the students before, for instance, in a distant phase, and then in a residential phase all together.
And what is hybrid?
Hybrid means that in the same time you have some students in the class and some students not in the class.
Okay, all right, thank you.
Okay. There are different definitions, but usually I consider this one, okay? Then people also, you can pay attention also to the time dimension, okay? But usually I use with respect to the space dimension. Then a lot of activities in asynchronous ways. It means that also people can do in different times. If I am in USA or in Italy, I can do, for instance, I can answer or discuss in a forum with my peers in different hours, but allows also to work together. So in order to summarize the function of a digital learning environment, the functions are creating and managing courses and activities, delivering and displaying activities and resources, collecting qualitative and quantitative data. Usually they are called learning analytics, analyzing and elaborating this data, and providing feedback to students and teachers. In particular, it's important to try to give this feedback not after 1 week or 1 month or at the end of the course, but during the course. It is very important. I put very quickly just the interaction in a digital learning environment. You can see the idea is that there are a lot of arrows, and inside this you can see that this is the part where there is the design of the activities. Teacher and instructional designers create and put availability, contents, activity, and so on. In this part, you can see that there are a lot of contents, always availability to the students and the teachers. But in this part, you can see the interactive activities, means that they work together and there are a lot of data collected, elaborate in order to give feedback and to change also the creation of the material. So what does it mean? That I have a lot of advantages of using a digital learning environment. Teachers, I can use a digital learning environment in order to create a practice community for teachers. It means also to exchange materials, ideas, and so on. They can put in practice an adaptive teachings to their different students with different styles of learning, and they can use learning analytics in order to monitor the learning processes. But from the point of view of the learners, they can create a learning communities or discuss to help each other. So they can practice adaptive learning according their time, their style of learning, and they can receive also when they are alone at home automatic feedback, also continuous interactive feedback. This is very, very important. But also for institution, it's very important to have a digital learning environment because it means to have a lot of data that, for instance, a university, a school, a Ministry of Education can use in order to define the educational policies, but also university can use in order to create a network and also to push for internationalization process at home. Okay, we have a digital learning environment. Which methodologies, teaching methodologies are announced by a digital learning environment? Let me say, at least I can tell 4 or 5 very, very quickly. The first one is the formative assessment. What is, I just brought here the definition according to Black and William, the bubble of formative assessment. What is if I use this didactic methodology, it means that the teachers and the learners can make a decision about the next steps using what? Using the evidence about the students' achievement and during the activities. This didactic methodologies is fortunately now is quite used also at university, but is much more used in the secondary school. If I have an automatic formative assessment, I can put together automatic assessment together formative assessment, and I have automatic formative assessment, which is this characteristic, availability. These tests are always available to the students. We can organize them in the way that the students can have multiple attempts, and also we can prepare the test in order to encourage positive motivational beliefs and self-esteem. Then, as I already told you before, I can prepare algorithm-based questions and answers. It means that students are more also concentrated on the process and not only on the results. I can prepare questions where the answer are words, numbers, symbols, table, graphics, diagrams, and not only multiple choice. And for mathematics or in general for scientific discipline is very important. I can give immediate feedback. Is right, is not right. If wrong, this is the right answer, but also interactive feedback providing a step-by-step guided resolution, as I told you before. And finally, also to use real contests, real problems connected to the different courses, different bachelors or different contests for very close to the daily life of our students or useful for the career that are supposed to do after the bachelor and master degree. So if I can say use a 10 good reasons in order to use a digital learning environment in order to put in practice formative assessment is that you can read here for the students availability, immediate interactive feedback, but also adaptive learning and auto-assessment, learning from mistake, and also to learning to learn the respect for rules. That is very also important because the computer is stupid if you write in the wrong way. Also, if you make a few mistakes, of course the answer is wrong. But the teacher can share a lot of questions to create a repository with their colleagues, can save time in order to correct, can change the roles also to when prepare materials have changed the role and to check from the point of view of the students, can give feedback, can adapt their teaching. So again, here you can use in this picture in different way at home, in the class, and so. Problem solving. This is the cycle of problem solving connected to a real world situation. To have an advanced computer environment is very important when I discuss and when I try to find the right strategy in order to solve the problems. And also it's very important also in the phase of the generalization. Why? Because if I use an advanced computer environment, I can extend ways of reasoning on mathematical tasks. I can enhance the exploration using different representation, and I can use also interactive component in order to explore in a dynamic way. And I can use parameter in order to generalize the solving process of a problem. So to have this tool in a digital learning environment is the problem solving, which is of course a didactic methodology used from many years, but real change if you use if you use the technologies, in this case an advanced computer environment, during the activities. Also for not only for the problem solvings, but also for the problem posing, which is also very important. For instance, you can see in this slide, you have this component interactive where you have this, for instance, these slides. You change the numbers and you have a geometric visualization of what happens. Okay, also this is for study of signals and so on. We used a lot of problem solving, for instance, in a blended intensive program. You know that now we have these new short mobilities in the Erasmus Plus programs. And for instance, we developed this blended intensive program called Problem Solving and Critical Thinking, where we put students from in courses of security and defense area. We put students from different universities together before for 2 weeks in a online phase together to solve real problems in the context of security and defense. And then in the residential phase they use always a digital learning environment in order to solve problems connected to a scenario. Another methodology is the collaborative learning, especially among students, but also among teachers. We developed, for instance, a COIL, Collaborative Online International Learning. The topic was linear algebra for economic, finance, and security and defense strategies. Again, this is we developed, for instance, here in Torino with the Dublin College University. This COIL students, they study linear algebra, but the courses are very short and we don't have enough time in order to show them the application of linear algebra, in this case in economic, in finance, and security and defense context. And we offered to the students of this at University of Turin and at Dublin University College in Dublin, the possibility to work in the afternoon together in small groups in order to solve problems using linear algebra. And the collaboration can be done also in an asynchronous way, as we saw before. And another didactic methodology is the adaptive teaching, because it's very important, especially when you have students with special needs. You need to prepare materials in order to help them to reach the same learning objectives, the same learning goals. And using a digital learning environment, it is really possible. And of course, it's useful also for students, very good, because otherwise, if you want to keep the engagement very high, you can also prepare materials for students very quick, who are very quick in answering, and also to allow them to develop higher competencies. Let me finish to say a few words about gamification in a digital learning environment. You know that gamification is a didactic strategies quite used in different contexts. What is gamification? The term of gamification refers to the use of the typical mechanism of the game, such as challenge, the use of points, level, and prizes in a context that is essentially is not a game. Example of strategies: storytelling, rules, leaderboard, feedback, rewards, use of points. These are some of the most common gamification elements. Then to consider when we want to design some gamification strategies in a digital learning environment. Well, if, for instance, I use, this is an example, the plugin Level Up is a very easy plugin that you can use in a digital learning environment. You can use it to do what? To involve students as part of a mission, challenge, even as a group to complete, define the activities that the students have to complete to automatically earn points, to monitor the progress of the learner's activities to a personal report, to download and process data within a spreadsheet, to issue badges on achievement of milestone. This is a case study that we used this tool in order to develop gamification strategies in a project which involved 3,000 students of the secondary schools. And also we try to use these gamification strategies in order to achieve the sustainable development goals of the Agenda 2030. And we introduce, for instance, digital math equals. We insert 17 levels in order to reach the goals of the Agenda 2030. And we use it in order to rewards with the personalized message for each level achievement in order to give the badge for the next level achievement. It was quite easy to use it. It's a very good experience, and you can keep all inside your digital learning environment. Inside the digital learning environment, we also try to integrate a serious game. This serious game is called, for instance, the Assassin of the High Tech Institute, and the game is accessible to students anytime, anywhere. And the main aim is to facilitate and enhance students' approach to mathematics by providing an engagement and interactive environment. In particular, this serious game was used in order to learn the differential calculus. And the students was very satisfied in using it. Let me conclude saying a few words that there are theoretical frameworks to build digital learning environments. Of course, we are inside the philosophy of the constructivist philosophy. According to Glaserfeld, learning is a lifelong active process of knowledge building mediated by experience and relations with the environment and the community. According to this, we have that the technology can support the creation of constructivism digital environments through computer-mediated communication, computer-supported collaborative work, case-based learning environments, computer-supported cognitive tools. And we find if we check, for instance, this on the right, you can see how it is organized a problem-solving and critical thinking digital learning environment of this blended intensive program. You can recognize very, very easily these different resources, activities, challenge real-world math problem, forum to discuss about how to solve the problem, submission of student solutions, self-assessment questionnaire, interactive solution. And these activities are according create-based learning environment, computer-supported collaborative work, computer-mediated communication, case-based learning environment. We can find all the peculiarity of the constructivism philosophy. We know that there are 7 goals for building learning environments, and you can find here to provide experience with the knowledge construction process. And we put on the right the activity or the resources that you can have inside the digital learning environment according to these 7 goals. In the first case, problem-solving interactive activities, or to provide experience in and appreciation of multiple perspectives. And with respect to this, you can design exploration or to insert interactive feedbacks, or to embed learning in realistic and relevant context. We can use use real-world problems for the students, or to encourage ownership and voice in the learning process. And we can insert interactive activities and automatic assessment to embed learning in social experience, to encourage the use of multiple modes of representation, to encourage self-awareness in the knowledge construction process, and again using forum discussion, classroom activities, exploration, algorithmic questions, or immediate feedback, self-assessment, we can reach these 7 goals. So thank you very much. I try to keep in the time that you allow me, but if you have any question, I'm available.
Thank you very much, Marina. You kept the time without speaking as fast as the Italians usually are doing. Excellent. I have to say that it was like the first lecture session that I have followed all these years, that, I don't have space on my notes. On my notebook, I have so many notes and so many, it was very inspiring, your presentation. Congratulations.
Thank you.
We have 7 minutes for questions because I have to move to my class. I have some questions, but I will provide the floor to you in order to ask first. But go to the point, please. direct to the point and direct, the answers.
And may I
Yes,
pose a
yes,
question?
John, please.
Yes. So we have this case that you would like to help the student a little bit to help them to get on the way to the right solution, rather than just saying false or true. And gamification is sometimes not in accordance with that. So do you have any conflict resolution examples of how you could use gamification?
Good question. In the gamification, it is not easy to prove that the effectiveness of the gamification strategies or serious game in improvement of learning. In this moment, we develop these two serious games for mathematics, one for calculus and one for statistic. And we tried to, we are doing in these months an experimentation at the first level of the bachelor, using asking students to do some activities and to try checking all the data that we collect, the answer, the mistakes, and so on, to try to understand that if they effectively improve the learning processes. But it is very complicated to do it. The students are very happy. They enjoy and the engagement is high. But we would like to have a scientific proof that they really improve the learning processes.
Okay, thank you.
Thank you very much, John. Probably Marina, I think that, in one of the previous projects that, I have been involved, I found out that what does it work regarding the mistakes, but, by noticing, let's see, not, by scientifically can back up this, was the frequent testing. So you're using learning analytics, you're doing frequent testing, and from the frequent testing at the end, you can collect, what are the usual mistakes. And now with the help with AI, AI also can enhance you and, can map in the future what other kind of mistakes based on the background of the students they have. I have the data. I have worked, out, but, I'm from a different discipline, but it was very, this is like my experience. How does it work? And probably sometimes I'm thinking that regarding gamification and what John has mentioned, probably, already available tools like Kahoot can be engineered in order to ask these kind of questions through a gamification that the students usually they are doing mistakes. And then in combination with what Marina has presented, you can do very nice things. So now, Marina, I would like to ask you my question. I have a lot of, but I don't have time. So I would like to ask you, how do you motivate your students to participate in COILs? Because you mentioned this is an excellent idea. I like it very much that you can also present applied things in anything related to STEM. This was an excellent idea. I kept this idea and I will leverage it. But how do you motivate them to participate in extracurricular kind of activities? I have an idea, but I would like let you speak first.
This colleague from Dublin asked me to develop this coil, and I accepted with pleasure. And the participation was voluntary participation.
That's why
We didn't give more points for the
very correct.
They explained them that the course is very short and linear algebra.
How short? What do you mean short? In
short
weeks?
means that I have a few. The linear algebra is a part of a mathematical based course, and we have between 8 or 12 hours of linear algebra. Okay. So it's only a part of course, and I explained them that I don't have the time to show you. I just showed one very short example where to apply the linear algebra. So I suggested them to participate, but I presented the activities also as an occasion to meet friends, to develop linguistic skills, to not only for maths, okay, but also a more cultural experience. And we gave them at the end a certification that can be used also for the CV, that they attended these activities. And when we presented, I must admit that we decided to have only 20 students, not all the students, because 20 Italian students and 20 Ireland students, Irish students.
Iris, yes, go ahead.
Irish students, and we, in a few hours, the students answered to a questionnaire in order to do these activities. It was very easy. We just presented the activities.
Yeah, but my question is the following. It's like you mentioned 20 of how many sessions regarding COIL did you have? What was the duration of each COIL session? This was my question.
Okay, we had 40 students and 10 groups. The COIL started for 40 days, the duration, 40 days. We they had two meetings all together with the students at the beginning, at the end. At the beginning, we presented the problems and the activities. At the end, they presented the short videos that they were supposed to do in order to show the solution to the problems. And in the middle, we presented the two series of problems, one connected to finance, one connected to cryptography, and they were supposed to have 2 or 3 meetings. They were free to organize the meeting online for the team.
Thank you, Marina. I have to close because I'm late 1 minute, and here they are very strict. I would like to thank you, all of you. Really, the last 2 sessions of this series of Pythagoras for me was like incredible. Very enriching. So I would like to thank you also for your participation. You show like your real motivation in order to participate in this kind of series of sharing knowledge and ideas. Have a nice time and stay safe.
Thank you
Bye.
very much.
Thank you,
Thank you.
Marina, and thank you, Kostas.
Thank you.